So I'm recording this. Hello everyone, welcome back to Dragonfly Engineering. So this week we're going to cover mold cooling, which in the past I've said I don't always need to worry about using aluminum molds, but in some cases, for instance the Gametammer mold, which is a couple of large parts that take up a large amount of surface area of the mold itself, molded in polypropylene. Well, polypropylene is actually kind of a high heat capacity plastic. So when you set up to mold maybe 50 parts, it's not that big of a deal. But after that, you know, like one round of parts per minute for 4 hours, the mold basically heat saturates and gets too hot. And what happens is you start to get defects in your part from the plastic not solidifying enough to be rigid enough to withstand the forces of ejecting the part out of your mold. So you start to get things like ejector pins will push into your part because again, it's not cool enough to be hard enough to resist the force of ejecting or overcoming the friction of the part being stuck in the mold itself. So with aluminum molds, you still do have to get the heat out of the mold when you do extended production runs. For small prototype runs, like I mentioned, 50 parts or less, it's not that big of a deal because aluminum conducts heat. Like, I think it's 230 watts per meter Kelvin to be all scientific, where steel is like 20 or 30. So aluminum conducts heat about 10 times more than steel does. But you know, when the whole block becomes super hot, you're still stuck with parts that are still half molten trying to eject out of your part. So I'm going to show you how I heat sunk the Gametammer mold, which again was 2 polypropylene parts with a large shot size, thus a lot of heat being added to the mold. And what I wound up doing was machining a profile into the mold plate, so the A-side plate, which I actually put on a separate mold. You know, these are both 12 by 16 inch molds actually the mold bases are from American Quality Molds. So AQ molds, if you want to check them out online, they're not sponsored or anything, but they're pretty cool and pretty good prices, and yeah, they're made in the USA. The airplane coming over, so let's pause for a second. All right, so we're back. So if you look at the A-side face of this mold, where the clamping plate is not actually bolted on, like this plate here, you can see the impression of a channel here that starts here, goes all the way around and comes out here. And what that is basically a piece of copper that I pressed into the backer plate for the A-side. And I'll show you how I did that, but here's the same plate, and since these are both the same standard mold base, I can actually swap the backer plate on the A-side, which you use to clamp the mold to the mold platen with this groove right here, with its copper cooling line pressed into it. So basically what I wind up doing is I machine a channel on the other side of this plate, and then I press in this copper line, and then solder on some fittings for hoses for the water pump and the chilling system to cool down the A-side of the mold. So anyway, this is the impression on the Gametammer mold, but I swapped that whole plate out and I put it on this other mold, which I think was like an ABS part, like a big frame part. I could probably show you what came out of that mold. Yeah, in this mold there was like a plastic part like this that which also has a decent heat capacity when you're cranking them out one every 40 seconds or so. This mold would heat up too, so I put the chiller plate on this mold as well. Now for the B side of the mold, if I rotate this, you still got to chill the second half of the mold. So this is the parting line right here, the A block and the B block. So we got the A block covered with this chiller plate, which again is on this one. But for the B side, what I wind up doing is a similar technique And this is a cold plate that you can buy from McMaster Carr online, you know, industrial supply company. And it actually comes with 2 mounting holes, I think, or maybe I drilled those 2 mounting holes. But you can bolt these plates onto your B side like that and sink the heat out of the B side of your mold. If you don't have real estate to actually drill, like gun drill deep holes and then have a cross channel at the bottom and then, you know, cap the holes so that you can basically drill in your own chilling circuit. But that's kind of a hassle. Some machines aren't big enough to actually drill a 15-inch deep hole and have it not lead off too much. And then you got to side drill, get all the holes to interface, and then you got to plug all your cross drills with a plumbing cap. And it's sort of a hassle, but it's easier just to set up and machine one groove. So let's take a look at how I did that, and I'll show you some of the issues I had with pressing the copper in and some of the soldering I did. And then always remember, for the B side, you can just buy these chiller plates, and I basically have this as a set, you know, and this would cool both sides, and I think this one even chilled the top. You can get smaller chiller plates as well, which again is just crimped in copper line with flexible hose and hose barbs. Okay, so let's go over to the mill and we'll do this. And thanks for watching Dragonfly Engineering.
Why must life be so